Right. Good morning and good afternoon, depending on where you are. And welcome to this presentation. The title of our project is Genetic Improvement of Dried Beans for Bruchid Resistance for Southern Africa. So I'll give an introduction of our project. It's focused on common bean weevil, which is a serious post-harvest pest for us here in Southern Africa, but also for the rest of Africa. So there are two types of weevils that we get, but the most prevalent one for us here in Southern Africa is the common bean weevil, which is Acanthosylex obstetricus. This weevil is responsible for major post-harvest losses. It damages the seed, which makes it unsuitable for consumption, and also messes up with the germination ability of the seed. And what I'm showing there is a snapshot of the pest itself. So our project is focused now on this pest, and we are trying to achieve about 4 objectives. The first objective is to develop and release Bruchid-resistant bean varieties that have good agronomic performance in market classes that are preferred in Malawi, Mozambique, and Zambia. And again, then the second objective, we are trying to develop modern breeding tools to improve on the efficiency of selection for weevil resistance. It's not easy to select for resistance for this pest. It's quite a time-consuming process. It takes almost more than sometimes close to 2 months in terms of screening for resistance. Now we are trying to develop modern breeding tools, molecular tools that could help us make this process, this selection process more efficient and quicker. Then the third objective is to determine the cooking time of these weevil-resistant varieties or Bruchid-resistant varieties that we develop. And the fourth objective is to train the next generation of crop improvement scientists. Here we are going to train a number of master students from these 3 focus countries. So introducing my research team, we have the PI, the lead PI is Dr. Juan Osorno, who's from North Dakota State University. And then there are now 5 of us who are the co-PIs. There is Phil McLean, who's a professor at NDSU, and Carlos Urea, who's a professor at University of Nebraska-Lincoln. Then Virginia from the Department of Agriculture and Research wing from the Ministry of Agriculture in Malawi. Then Celestina, who's the bean breeder in Mozambique from IIMA. And then myself, who's from Zambia. So, like I said, the project is focused on 3 countries. That's 3 Southern African countries. That's Zambia, Malawi, and Mozambique. So, although the focus is on these 3 countries, we anticipate the impact of the project to be much broader than these 3 countries, given that we are working on market classes that are preferred not only in Southern Africa, but also in East Africa. So where does the resistance come from, this Bruchid resistance that we are working on? I need to give credit to the people who pioneered this work. The work was initially started by Dr. Paul Kusolwa, G. Myers, and Dr. Beaver. These are, and plus other researchers. These team, what they did was to move the Bruchid resistance from temporary bean, because initially we didn't have resistance within common bean. So we had to move that resistance from temporary bean and introduce it in common bean. Yeah. And through that work, they managed actually to develop and release a variety, which is that with that long name. It's a red bean variety that they developed, and the details are in that paper which they released. So what we've done now is to kind of move this work further and to try and deploy these Bruchid resistance now from this market class and deploy it in a lot more market classes. That's the market classes that are preferred in these three focus countries. But before doing this work, first we had to do a proof of concept as to how transferable is this resistance. Like I said, the resistance is originally from temperate bean, and it's the APA locus, which is on chromosome 4, that actually controls that resistance. So previous work we've tried to, we did work on to, trying to cross this a source of resistance with some of the materials that we have here in Zambia, and see whether we could transfer that resistance. And indeed, we did demonstrate that that resistance could be transferred from that particular market class into various market class. And what I'm showing you here is one of the lines that we did develop out of that cross that we made between the resistant line and the susceptible line, which is SA181. It has a resistance to this Bruchid, demonstrating that indeed we can then scale up this work into other market classes. So what are the market classes that we are targeting? We are targeting almost about 5 market classes. We are targeting the pink mottled market class, then the red and the purple market class, which is commonly referred to as Kablangeti for us here in Zambia, and then the red mottled and also the cranberry, or commonly referred to as the sugar types for us here in Southern Africa. These are the most important market classes that we have for us in Southern Africa. And we feel by introgressing resistance into these market class will have a much broader impact for our farmers and consumers here in Southern Africa. So how do we go about with our screening? Before we could actually start our breeding work, first we had to test the protocol to try and adapt it for our screening work here in Zambia, and also for our partners in Malawi and Mozambique. What we do essentially is to get the seeds into these bottles, and then we introduce the weevils in there. And then after about 45 days, we got to measure the levels of resistance depending on the perforations that are there, and also using the other metrics. We have adapted the protocol. It works now very well for our screening work here in Zambia. So after doing that, the next thing was now just for us to begin screening of our materials. Now, what are the materials that we have developed? The materials that we are working with. So like I said, we've crossed this resistant line, crossed it with several materials that have better agronomics. They have the productivity, and most of these materials are coming also from the layer and diversity panel, for which we have a better sense of the productivity of these materials. And under that, we developed just more than 1,650 of these F5 materials that are currently growing in the field as I speak. And but prior, even before the development of these populations, we already had 2 populations that we are working with, which were crosses between Kablangeti and Solwezi, crossed it with the resistant line. This AO3A. These materials are a lot more advanced, and currently we are just increasing the seed, and then we also started working on screening them. and the cross between the resistant line and Solwezi has already yielded very positive results as we managed to identify some of the resistant lines. So what I'm showing here is just now to give you a sense of the variation in terms of resistance that we have in one of these populations, which is a cross between Solwezi, our preferred landrace here, but susceptible to the weevils, crossed with the resistant line. And what we see there, you could clearly see that we have some of these lines that show very good levels of resistance. And those are about 7 lines which I've listed there. And these, we are quite confident in terms of their levels of resistance that, that they could be acceptable to the farmers. What I'm showing here now is what we have there as a susceptible variety. This was one of the parents which we made out of, which went into this cross of Solwezi and the resistant line. And on my right-hand side, the picture there, you are seeing SA181, which is one of the lines that has come out of this cross and has very high levels of resistance to Bruchid. We're excited about this line because the seed type is that type which is preferred for us here in Zambia, but we are also anticipating it to be acceptable for our consumers, say in Malawi. But this is just one of the crosses, and again, it has it's some sort of testing. I mean, for the proof of the concept that indeed we can move this resistance from this resistant line to deploy it in various market classes. We are currently doing seed increase of this particular line. Again, here I'm just showing a display of now the way the screening was done, and for this particular line in terms of how it shows up now in a fine detail in terms of in the different replications, how it comes out. Like I said, we've already, I mean, just about 2 weeks ago, we were very busy planting our breeding lines. Those there were more than 1,650 lines I was talking about in various market classes, and also the lines from our 2 developed populations. And this just gives you a snapshot of one of the nurseries that we have in the northern part of Zambia. So we are advancing these F5 lines, and they'll be ready for our, once we harvest them, then they'll go into our screening pipeline to now identify which among these 1,650 lines are resistant. And then we are also doing the seed increase for those lines which have already identified to be resistant, and that's the seed that we'll be able to ship to Malawi and Mozambique for agronomic evaluation next season. That's the 2022 growing season. Prior to that, I mean, it was last year's season. We had a nursery of of our materials that came out of these 2 populations. Again, that just gives you a sense of the nursery that we had and of the materials that were there, which were from these 2 populations that already have the advanced lands. So what I've been showing now has been mainly in terms of what we've been doing on the breeding work. That's developing these breeding populations and also screening these materials to identify the lines that are resistant. But we also have these other activities that I can give you an update on. Like I said, the other objective is for us to develop molecular tools that could bring about efficiency in our selection for Bruchid resistance. And this work will be undertaken at NDSU, North Dakota State University. That's where we ship materials, and the lab work will be done there to identify markers that we could be using to enhance the selection efficiency for the APA locust. Then we are also going to be conducting the cooking time evaluation of the Bruchid resistant lines. We use the Matson cooker in a lab setup and also conduct on-farm cooking trials. Meaning we'll go onto these onto farmers into farmers communities and conduct cooking trials on those lines that will be that we find to be Bruchid resistant. Like I said, capacity building in terms of graduate student training is a major component of our project. And under this project, we are looking at training 3 students from Malawi, Mozambique, and Zambia who pursue their degrees in plant breeding and seed systems here at the University of Zambia. And 1 student will be trained at North Dakota State University at a master's level. He'll be in Dr. Juan's lab there. So in conclusion, what we've been able to achieve so far, we've been able to develop breeding lines, and we've also been able to actually test the screening protocol, optimize it for Zambian conditions, and we've adapted for its use here in Zambia. It's working well, and now the pipeline is somewhat set up in terms of our screening process. And like I've already mentioned, we've even been able to identify some of the resistant lines from those populations that are already ready. We are now in the process of finishing the development of these breeding lines and then pipe them into our screening process to identify now more Bruchid resistant lines in more diverse action. And I would like to thank the Legume, the Innovation Lab for the Legume Systems who are providing this support to the SID, the University of Zambia, IIAM of Mozambique, where Celestine is coming from, the University of Nebraska, where Carlos Urea is coming from, NDSU, where our PI, Juan Osorno, and Phil McLean are coming from. And then from DAS, Department of Agriculture Research Services in Malawi, where Virginia she's coming from. Thank you.